Alright, this is for section 2.2. I have seemed to find out that if I keep the video segments less than 5 minutes, I should be able to easily upload them into Canvas. So from now on, I'm going to just do a problem at a time per video to hopefully save myself some time moving forward here. So the first problem you had asked Mr. Joseph was number 22. The question reads as follows. For each correspondence, write the domain, write the range, and determine whether the correspondence is a function. These are the correspondence I was given. 0, -1, 1, 3, 2, -1, 5/3. If we remember, domain is equal to x, while range is equal to y. So just to save some time, I'm going to put x and y as you normally would with anything else. X and y. So then now I'm going to just repurpose these. So 0, 1, 2, and 5. Of course, as you follow along, 0, 1, 2, 5 is going to be my domain, while my range is going to be -1. And I wish I had a better marker, but we'll work with what we got. 3, -1, and 3. So looking at both our domain and our range, our domain is 0, 1, 2, and 5. There are no repeating numbers, so this is a function. However, down here, as you can see, -1, 3, -1, 3, they just kind of repeat. It does not matter. These will work for our domains. So technically, we would write this as 0, 1, 2, 5, and -1 and 3, since we have repeated those twice. Alright, Joseph, I am now back with the second problem for section 2.2. I'm going to kind of zoom this in. Hopefully it doesn't blur out too much. My phone is a POS sometimes, and I don't mean point of sale when I say that. So the question that is asked is determine the domain and the range of each function. So looking at our graph here, the biggest giveaway I can say right now is due to these arrows. This means that both x and y are infinity. They don't have an exact start or stop point. Unlike down here, if you look at this problem, while the x domain, or not the x domain, this part is continuous, it eventually ends on 3. So going back up to this problem, that was the one we're focusing on. All domains are real numbers. So as you can see, as you've mentioned before in your lecture videos, as long as this line is just going to continue forever into the negative zone, it goes up to here to positive, and then it continues back down to y negative. So our real numbers are infinity 0, 0. As I mentioned, it just continues going down, and then positive 0, 0. Hopefully I explained that a little easier than as bad as it may have just sounded, but we'll go with that. Alright, I am now back with section 2.2, problem number 42. I hope I wrote it down right. So, it asks to find the function values for this equation right here, h of x equals 5x minus 1. So to save some time here, I already wrote down our main formula, which is right up here, h of x equals 5x minus 1, while over here is each problem that it asks us to plug into our formula. So to start off with, a is going to be h of 4 equals to 5 times 4 minus 1. So with all these problems here, except for kind of these last two, I'll explain in a little bit, we are plugging in our number 4 here and for x. So since we have both x here and here, this is where we get here. So now we just solve the solution. So 5 times 4 is 20 minus 1. Now, I don't like to carry this down until the very end just because it confuses me, so technically I believe you are supposed to carry down this first part of the equation, but for all intents and purposes, this is just what I do. So going back over here is going to, so 20 minus 1 is simple arithmetic, is 19, so h of 4 is equal to 19. This is our final answer for section, or letter A. Let's try that again. So I'm going to move on to B since I still have some time before my 5-minute time. So same thing again. H of x, which is going to be 8. So h of 8 equals to 5 times 8 minus 1. So same thing, we're going to solve like terms. Bring this down. 5 times 8 is going to be 40 minus 1. Do the simple arithmetic. Subtraction, so 39. So h of 8, that's a horrible h, but we'll go with that, is equal to 39. Going over to number C, we're going to plug in -3. So h of -3 is equivalent to 5 times -3 minus 1. So starting off with order operations, once again, we're going to do parentheses. So 5 times -3 is -15 minus 1. Combine or do the equation here, so -16. So h -3 is equivalent to 16. I'll be right back. I need to make some room. Alright, I am now back, so we are going to continue on with letter D. So following the same exact formula that I have, I'm going to plug in my number, where x should be -1. So 5 times 4, or -4, sorry, is a -20 minus 1. Do the math, is -21. Did I do that right? I think I did. I'll show my thing at the end here. Yeah, so 21. So h of -4 is equal to -21. And then now when we get to E, it gets a little bit more trickier since we have a -1. So we're going to put both the a -1 where x should be. So it's going to be h of a -1 equals to 5 times, what did I write? Here we go. 8 minus 1 minus 1. So, order of operations, again, we are going to now multiply the 5 to the a into the -1. So 5 times a is going to equal to 5a. 5 times -1 is -5, so we put -5. And then -1, you just bring that down. Now we're going to continue with our problem. Combine like terms, but since we cannot combine 5a with anything else, that just continues down in the equation. -5 minus 1 is a -6. And we can't do anything else with the equation at this point. So our answer is going to be h of a minus 1 equals to 5a minus 6. Since I am at my 5-minute limit here, I will continue on with F in the next video. Right, I am now back since I accidentally erased my main equation, so I had to rewrite everything. So for problem F, same thing, I'm just going to plug in all of this into the equation. Now what's different with this is this +3 is actually going to go on the end, while the a is going in place of x. So going back over here, so h of a plus 3, because this whole part still needs to go in, equals to 5 times a minus 1 plus 3. Because remember, this +3 still applies. So now we're just going to continue with our problem here. Look at my notes over here. So 5 times a is going to equal to 5a minus 1 plus 3. Continue down, combined like terms. 5a I obviously can't do anything with, so this comes down as 5a. And then now -1 plus 3 is going to be a +2, so plus 2. So h a of a plus 3 is going to equal to 5a plus 2. Alright, I am back now with the last problem that you have asked me to show you how to do, even though I am probably not doing very well with whole teaching aspect, but we'll go with it, and my phone does not want to work right now. Alright, so the question is find the domain of the function given by each equation, so hopefully you can zoom in a little bit there. So the equation that is given is f of x equals 5 over 2x plus 1. So I'm going to write that real quick just on the top up here so I remember what the equation is, so I am not trying to guess or write down the wrong one. So okay. So our keyword here is find domain. So if we remember, domain is the same thing as saying is equal to x. So this top part of the equation, there's no x with it at all. So we're just going to kind of just imagine that it's not there now. So we're going to focus on this bottom half of the equation. So we're going to rewrite the equation. F of x equals 2x plus 1. Now, in order to find the domain, we need to make this part here into 0. So we're just going to add 0. Now we're just going to solve the equation as we normally would in algebra. So we need to move this 1 over here to where the 0 is at. So we're going to do a -1 on both sides. So that's going to equal to 2x equals -1. Now we need to get x by itself. In order to do that, we need to divide it by 2. So this gives x on its own down here. So then x is equal, I don't know why I did that, probably didn't need to do that. Anyway, so x equals -1/2. This is negative because even if you were to divide the 1 by 2, it's still going to be negative. So this is our domain. So, or not, sorry, not quite yet. So our domain is all real numbers except when x equals to -1/2. And that is our answer.